Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the May-June 2020. This is the International A-Level Cambridge 9709 syllabus, paper 1, variant 2. This question here is about arithmetic progressions, and we're told about the nth term of an arithmetic progression is given by a half times 3n minus 15. We've got to find the value of n for which the sum of the first n terms is 84. So in the formula sheet, you'll see some formulae. One of them is un equals, now for arithmetic progression, it's going to be a plus n minus 1 times d. That's one formula you're given. And you're given another formula for the sum of the first n terms, which is n over 2 times 2a plus n minus 1 times d. Okay. And so we got to find the value of n for which the sum of the first n terms is 84. Okay, so now, first of all, we're gonna make the Sn equals 84, and we're gonna find the value of n. So really, we need to find the value of a and d, so that when we put 84, we replace 84 with Sn is replaced by 84, and a we have to find. We have to find what n is. Can we work out a and d from what we have? Well, yes, we can, because we know the nth term is given by a half times 3n minus 5. The nth term is a half times 3n minus 15, sorry. We can use this to work out the first term. A is the first term, which is basically u1, when you put 1 instead of n. So it's going to be a half times 3 times 1 minus 15, which is going to be a half times 3 minus 15. Now 3 minus 15 is minus 12. Half of minus 12 is negative 6. So we know the first term is negative 6. And if we work out the second term, we can then work out the common difference. In fact, we should know the common difference is 3 over 2, because this is 3 over 2n minus 15 over 2. This tells you the common difference. The number you have to add by each time to get to the next term is going to be the number multiplying the n. But just to confirm it, we can put here a half times 3 times 2 minus 15, which is going to be that's going to be a half times 6 minus 15. Now 6 minus 15 is going to be minus 6 minus 15 minus 9. This will be minus 9 over 2. Okay, so that's the second term. So the first term is negative 6, and the second term is minus 9 over 2. So what is the common difference? It's what you get when you subtract these. When you do negative n minus 9 over 2 minus 6, well, that's going to be minus 9 over 2 plus 12 over 2, which is going to be 3 over 2. So as we mentioned, the common difference, therefore, is going to be 3 over 2, which you could have worked out by just looking at the coefficient of the n, because that's the number you have to add by each time to get to the next term when you have the nth term. So you could have just written down that from this if you wanted to. And we know, as we said, a is negative 6. So now we have the value of d and a, and we have Sn equals 84. So now we can use this formula here. So we can say Sn 84 is equal to n over 2. We have to find n, so n over 2 is going to be as it is. 2 times a, 2 times negative 6, plus n minus 1, we don't know what n is, times d, which is 3 over 2. And that is now a formula or an equation with just n in it. So I'm going to have here, let me just write the n on this side. So n over 2, that's going to be minus 12. And you're going to have plus, and I'm going to expand that, 3 over 2n minus 3 over 2 equals 84. Let me multiply both sides by 2 first to get rid of this fraction. So we have n times minus 12 plus 3. In fact, we can add these together. You're going to have 3 over 2n. 3 over 2n minus 12 minus 3 over 2. Well, that's going to be minus 24 over 2 minus 3 over 2, which is minus 27 over 2. So that's supposed to be with the n there, that one. Yeah, that's minus 24 over 2 minus 3 over 2 minus 27 over 2 equals 84 times 2, which is 168. So now we're going to end up with this quadratic 3 over 2n squared minus 27 over 2n. Let me just bring everything to one side. Minus 168 equals 0. I can multiply both sides by 2 to get rid of this fraction. So I got 3n squared minus 27n minus 168 times 2. 168 times 2, that's 16. 2 16s, 2 6s are 12. And that's going to be 336. Okay, minus 336 equals 0. Everything is divisible by 3 to make it easy to solve. N squared minus 9n minus 118 equals 0. So we got to factorize this. We have n, we have plus and minus. So we've got to think of different ways of getting 118, and the two numbers multiplied together will give you so negative 118 had to give you minus 9. For this, we could use a quadratic formula if we wanted to, because they're a bit complicated. But we can even think, okay, let's see, 2 times 56. That's 150, no, 59. Okay, 2 times, no, that's not going to work. 3, that's going to be a plus 1. No, 3 doesn't go into it. 4. 4 into 11 goes 1 time. 2 times, sorry, remainder 3. Nope. No, remainder 3, that's right. That's 38. Nope. That's 5. 6. The 6 goes into 118. 6 goes into 11. 1 time remainder 5. No, 7. 7 goes into 11. 1 time remainder 4. No, 8. 8 goes into 11. 1 time remainder 3. 9. 9 goes into, doesn't, no, 10, 11, 12. I don't think, did anything go into 118 here? Why did I? Oops, supposed to be. My bad. That's 1, 1, 2 equals 0. So now we're going to try to factorize this. We'll see if we have two factors, one with a plus, one with a minus, n plus something, n minus something. Now they have to multiply to give you 112, and they have to add to give you minus 9. There must be different signs. So let's think of all the ways we can get 112. Let's see, 112, we're going to have 2 times 56. That doesn't work. 3 doesn't go. That's the other 4. No, 3 doesn't go. 4 goes into 11. 2 times remainder 3. So that's going to be 23 times 4. That's 112. That doesn't work. We have to have 9. 5, no, 6. 6 goes into 11. 6 goes into 11. 1 time remainder 552. No. Then we got 7. 7 goes into 11. 1 time remainder 4. So we have 7 times 14. That doesn't work either. The difference is 7. 8 goes into 11. 1 time remainder 3. Hold on. 7 goes to 11. That's 7 times 6, actually. That works. What am I doing? 7 goes into 11 1 time. Okay. Remainder 4. 7 times 6 is 42. Actually, it was 7 times 6. 16. 7 times 16. Okay, 7 times 16. That's 42. 7 ones are 7 plus 4 is 11. Yeah, so actually it was 7 times 16. So you're going to have a negative. So you're going to have a negative 16 and a plus 7. Okay, so there's a bit of work there to work out the factors that give us 112 as a product and negative 9 as a sum. And we worked it out. You could have used a quadratic formula here. We could have resorted to the calculator and got it done quicker. All right, but I just went through all the possible values. Almost missed it though. Did a mistake, but we got it. So we got n equals -7, which cannot be possible because it's a series. It starts always with the first term, and n equals 16. So therefore, we can say n equals 16 is our answer. We can't have a negative, term, or not. We can't have a negative position for a term. We can have negative terms, of course. The first term is negative, but the series or the sequence starts from the first term, n equals 1. So the 16th term is the term such that, okay, the sum of those first n terms is 84. And there's the answer to question number 4. I hope that was clear. Other questions from this paper can be found in the playlist, which will appear in this section over here. Other questions from the topic of series can be found in the playlist that will appear in this section over here. You can subscribe to my channel by clicking on this link, and over here you can find a link that will take you to subscribe to my channel. And you will notice that there will be some cards appearing, or there have been some cards appearing during the video. If you click one of those cards, it will take you to the material that I have, the links to all the material I have to my Cambridge collection. Thank you for watching, and see you soon.